Hey guys, we are going to do Chapter 7, Section 8 here. Most of this section, I'm going to try to clarify the best way to do one of these triangle proofs for those people that are still having a little trouble figuring out how to put a proof together. And I'm going to introduce how to use a new theorem at the end, and then we'll be done. All right, so let's get started. So you can see here that the new thing we're doing is given two, oops, I don't like it when it does that. Thought I did all this and still no, there we go. Given two triangles, prove that one particular pair of corresponding parts are congruent to each other. That's kind of the new thing of the day. But first, I really want to go back and break down how to do a proof better for you. All right. As we continue, so I'm starting here. As we continue writing geometric proofs, we should look at some of the easy one-step, maybe two-step proofs so that we can practice using some of the different theorems and properties and definitions that we have learned. A real key here is to know all of your definitions and properties, and I'm going to work with that on you the next few days as well. So, I bet you know most of these. Here we go. I want to prove that the measure of angle C is 50 degrees. And of course, I have a diagram over here, and you know that anything in a diagram is given, which is what I want to state first typically. So the first thing I might state here is that the measure of angle A equals 70 degrees, I suppose, and the measure of angle B equals 60 degrees. And that is given. So basically we're saying, if this is true, then does this have to be true? And I think you know it does. If those two angles are 60 and 70, then I think I can conclude that the measure of angle C equals 50. Do you know why? Well, this is one of the theorems we learned in the last day or two. It is the Tasty theorem. All right, that is the triangle angle sum theorem. Maybe we should abbreviate somehow. Triangle, therefore, angles equal 180 degrees. That's kind of what it says, right? That if you have a triangle, then the angles add up to 180 degrees. All right, let's go on to number 2. I have this diagram over here, and I want to prove that angle 1 is congruent to angle 2. So can you tell what information is given in the diagram? I intentionally did not write down what is given. I just gave you a diagram. And I'm hoping that from this diagram you can see that it is given that line A is parallel to line B. That's what these little guys mean, right? They mean that they're parallel. That is given. So does that allow me to conclude that angle 1 is congruent to angle 2? Well, of course it does. Do you know what theorem that is? Let's see. These two angles are corresponding angles. So the way I like you to do it is, if parallel lines, then corresponding angles congruent. Or, I suppose we could name the theorem, that is the corresponding angles theorem. But I kind of like better writing down what the corresponding angles theorem says. If parallel lines, then corresponding angles congruent. To me, that's a better way to do the proof. All right, number 3 might be my trickiest one I put on here. Prove that AB is parallel to DC. Well, I see what's given. The measure of angle C equals 130 degrees, comma, and the measure of angle B equals 50 degrees. And that is given. So is that enough to say that the top of this thing and the bottom of this thing are parallel to each other? So again, this I guess, comes back to recognizing what type of angles you have there and knowing your theorem. Do you know what type of angles those are? Think about it. If you consider this line here to be a transversal, and you kind of extend these lines, that's kind of the picture that you're used to, but you got to get used to not having all the extended lines. Those two angles are same side interior angles. And because they are same side interior angles, I have a theorem about them. We have a theorem that says when the same side interior angles are supplementary, then the lines must be parallel. We do. So before I can use that theorem, because it uses the word supplementary, I have to prove that those angles are supplementary, which of course they are. The measure of angle C and the measure of angle B are supplementary, and that is just the definition of supplementary because they add up to 180. And now that I've said they're supplementary, I can use this theorem. Now remember, this is the same side interior angles theorem. It says, this theorem says, if you have parallel lines, then, right, if parallel lines, then angles supplementary. I guess same side interior angle supplementary. But I actually want to reverse that theorem. I want to say if the angles are supplementary, then the lines are parallel. And so that is known as the converse of the same side interior angles theorem. The converse switches the if and the then. So this, in my opinion, is how you should write it. You should then say, I can now say that these lines, these segments are parallel. And the reason I know they're parallel, I guess the way I would write it is same side interior angles supplementary. Therefore, right, that arrow means therefore or then, parallel lines. All right, and all I've done here is I have switched the if and the then. So if you want to write this, if you want to write converse SSI angles theorem, you can, but I like the description better, right? All right, let's move on. One-step proof, number 4. Hopefully you know what these two angles are, angle 1 and angle 2. I want to prove that they're congruent. This is actually a true one-stepper. How do I know angle 1 and angle 2 are congruent? Well, they're congruent because they're vertical angles. And there's a theorem that says vertical angles are congruent. That is known as the vertical angles theorem, which from now on, if you are watching this video carefully, you can abbreviate as the VAT, the vertical angles theorem. All right, that brings us to number 5. And I want to prove that this angle, angle LKM, that would be here, and this angle, angle NMK, NMK would be here. I want to prove that they're congruent. Well, again, we get diagrams like this a lot, and I guess the first thing I should do is recognize what's given. And again, what's given is these guys, right? But these two lines are parallel. These two segments are parallel, I guess. So what's given is that KL is parallel to NM. All right. So you probably recognize this, but you know, if these two lines are parallel, and then of course I have this transversal right here, what type of angles are those? Those are alternate interior angles, right? And so we have a theorem called the alternate interior angles theorem. It says that when the lines are parallel, if the lines are parallel, then the alternate interior angles are congruent. Well, I have the if right here. If this is true, well, it is true, it was given, then angle LKM is congruent to angle NMK. And I like to write, if parallel lines, then alternate interior angles congruent. Or that is known as the alternate interior angles theorem. Okay, so look, here's the deal. I hope you understand those and they're relatively easy. What I'm trying to convince you today is that if you can do those little 1-2-step proofs, you can do big proofs, because a big proof is just a combination of 2 or 3 generally, of these tiny little proofs. All right, I'm going to show you that right now. So I'm going to introduce a new theorem here. I've mentioned this before when I gave you a list of all the theorems, but we're going to talk about it today. It is the CP-CTC theorem. So this theorem that we're going to look at today, it's abbreviated CP-CTC, but that stands for corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. And it says this: if you have 2 triangles that are congruent, then each of their corresponding parts are congruent. So here's where this would be used. If you were trying to prove that a random pair of parts on 2 figures, or triangles in this case, but it would work for any figures, were congruent to each other. Like if I had 2 triangles and I knew that this equaled this, and this equaled this, and this equaled this, then by side angle side, I would know those 2 triangles are congruent to each other. And once I know the triangles are congruent, then I can use this theorem to say, all right, that means that this side equals this side because those are corresponding parts of congruent triangles. So generally the order you go in here is first you prove the triangles are congruent. Then, because the triangles are congruent, you can say a certain pair of parts are congruent to each other. All right, now I have one more thing here. Now remember, proving that triangles are congruent is like doing 3 separate little proofs, like the ones we did on the front. You know, it takes 3 parts congruent to 3 parts congruent, particular parts, 3 parts congruent to 3 parts, as long as you get the right ones, right, for triangles to be congruent. So if I'm trying to prove triangles are congruent, I can break this down into 3 proofs. 1, prove that 2 corresponding sides are congruent. By the way, if I was proving triangles congruent by side angle side, if I was proving 2 triangles are congruent by side angle side, this would be my method. My little tiny proof number 1 would be prove that 2 corresponding sides are congruent. My little tiny proof number 2 would be to prove that 2 other corresponding sides are congruent. And my tiny proof number 3 would be to prove that 2 corresponding angles are congruent. And if I do that, then those 3 little proofs, then I can say that the triangles are congruent by side, angle, side. All right, I'm going to do a proof like this. All right, so it's given that angle N and angle Q are right angles. All right, so anytime something is given, I can mark it in the diagram. Let's go ahead and mark that angle N and angle Q are right angles. And segment NO is congruent to segment PQ. There's what was given. Now I want to prove that these angles are congruent to each other. Don't get confused by proving the angles congruent. My job here, well, let me make a plan. I wrote down the word plan over here. I'm actually going to make a plan. So my plan is going to be prove triangles congruent, then by CP/CTC angles congruent. So how do I prove the triangles are congruent? Before I actually do it, let's make a plan. I see I basically have 2 parts equal to 2 parts. But I do see another part, right? This line down the middle is going to be equal to itself. But that gives me angle side side, and that's not one of our methods, right? That doesn't work. But, ooh, I see it. These are right angles. And in these 2 triangles, I have 2 right triangles, and then I have the hypotenuse is equal because it's the same line. And I have a leg equal to a leg. All right, I think I see it. This is going to be my plan. Proof number 1 is going to be prove they are right triangles. Well, they are right triangles. They have right angles in them. Proof number 2 is going to be to prove that NO equals PQ. That's going to be easy. And tiny little proof number 3 is going to be to prove that, I've already forgotten my lettering, OP is congruent to OP. And if I can prove those 3 things, that's my 3 tiny little proofs, then the triangles will be congruent by the hypotenuse leg method. All right, those are the 3 things I need to prove for the hypotenuse leg. That I have right triangles, that a leg is congruent, and that a hypotenuse is congruent. All right, there's my plan. Let's do it. So step 1 is going to be prove that these are right triangles. Easy enough. So first, I'm going to state the given that angle N and angle Q are right angles. And that was given. Now, to prove that something is a right triangle, you just need to prove the definition of a right triangle. And I think that's in your notes, but the definition of a right triangle is a triangle that has a right angle in it. And I've now proven that. Angle N and angle Q are right angles. Therefore, triangle, let's see, let's call it NPO, and triangle QOP, you'll notice I kind of put those in corresponding order, are, oops, kind of ran out of room here, right triangles. And that is just by the definition of a right triangle. It has a right angle in it. So there is mini proof number 1. I have proven the first thing I need to prove to use hypotenuse leg. All right, the second thing I need to prove is that the legs are equal. That is right here. Well, shoot, that was given. So that's an easy little proof. All right, so my second thing I'm trying to prove is that NO is congruent to PQ, and that was given. All right, I've done the first two. I'm down to the third one. My third little proof is to prove that this line down the middle, OP, is equal to itself. Well, that's easy. We all know that one. We've used it a lot, right? How do I know that OP is congruent to OP? Well, that would be the reflexive property. And so I have my three parts equal to my three parts. Although in hypotenuse leg, it's not really three parts. It's a right triangle and then two parts. Same deal, though. So now I can say the triangles are equal because they are right triangles and their legs are equal and their hypotenuses are equal. So now I can go ahead and say, due to these three things, triangle NPO is congruent to triangle QOP, and that is by the hypotenuse leg congruence theorem. And then I can use our new proof, our new thing, CPCTC. Right? I wanted to say, originally, I wanted to prove this, that NPO, that this angle is congruent to this angle. And I now know that because the triangles are congruent, all corresponding parts are congruent. Therefore, angle NPO is congruent to angle QOP because they are corresponding parts of congruent triangles and therefore are congruent. All right. I hope that's good. You know, if you were doing a flowchart proof instead, you would take these two red ones up here, right? And you would have a circle for each of them. And then you would take this blue one here, and you'd have a circle for it. And then you would take this green one here and have a circle for it. And that would be your three things you have to prove. And then you could go ahead and feed all those into the triangles are congruent. And then that would feed into the corresponding parts are congruent. All right, good luck on the homework. I will see you next time.